Okay, to do the definition of the derivative, let's first recall the slopes of secant and tangent lines. So here's a secant line and some corresponding points. And what we're interested in is the slope. And the slope is the change in the y direction, in this case the change in the function. So the difference between f of x and f of a compared to the change in the x direction, and in this case that's the difference between x and a. And we'll take a look at the tangent line as well, and the important point here so the slope of the secant is the change in y over the change in x, or the change in the function compared to the change in x. And as we see, that can be written as the difference between the two y values compared to the difference to the two x values. And this part has a special name. It is known as the difference quotient. And as we saw before, as our x value approaches our a value, our secant slope approaches our tangent or instantaneous slope. And this slope of our tangent line, this instantaneous slope, is essentially our derivative. The derivative is written with this notation, f prime of a, and it is the limit, as we said, as x approaches a, to the difference between our y values and our x values. Another way to write this is using a new variable h, and here's the associated picture. We now let h stand for the distance we travel from a to our new point. So that's now a plus h. F of a is the y value, and our new point is f evaluated at a plus h. And there's your secant line. So our derivative at point A is the limit, and now h goes to 0. So we shorten the distance of h until a plus h is essentially right next to h, and we have a new part here where we have f of a plus h take away f of a, the difference in the y values, compared to the difference of the h values, which is just h. So difference of the x values, which is just h. Now that we can quickly find the slope, or use this to find the slope at a particular point, we can think back to Unit 1 where we were trying to find the equation of the tangent line, and now actually we have the point and the slope, so we can use the point-slope form of the tangent line. And it will look like y minus our y value that we know, which is f of a. The slope, which we can calculate, is f prime of a, times x minus the x value that we know. So let's try an example of putting some of this together. The tangent line equation to x squared minus 3x at x is equal to 2. So the first thing that we want to do is we'll know that f of x is equal to x squared minus 3x. We will need to know f of 2, which is 2 squared minus 3 times 2, or negative 2, and we need to go and calculate f prime of 2. And f prime of 2 is f of x minus f of 2 all over x minus 2, and we need to take the limit as x approaches 2. That's from the definition. So the limit as x approaches 2, f of x is x squared minus 3x minus minus 2 over x minus 2 is the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. The numerator factors, so we get the limit as x approaches 2 of x minus 2 times x minus 1 over x minus 2. The x minus 2's cancel. We can apply the limit and get a slope of 1. Then we can use the tangent line equation shown above. Y minus f of a equals f prime of a times x minus a. Substituting in for f of a is minus 2, for the slope is 1, and for the a value is 2. So I get y plus 2 is equal to x minus 2, or y equals x minus 4. We can check this graphically. Simply take your graphing calculator, plug in y1, which is our graph, plug in y2, which is our tangent line equation, and see if the tangent line equation works for the value of x equals 2 for our y1 equation. Go ahead and do that yourself. Okay, here's another example. We're going to compute the derivative of f at negative 2, where the function is 3x squared plus 1. So again, notice that we can find f of a plus h. So instead of the x value, we substitute in a plus h into our equation. So 3a plus h squared plus 1. And that gives us 3a squared plus 2ah plus h squared plus 1, or 3a squareds plus 6ah plus 3h squareds plus 1. So a little bit of algebra. We can also find just what f of a is equal to by substituting a in for x, so it's 3a squared plus 1. We need these two function substitutions so that we can use the other definition of a function, which is as the limit as h approaches 0 of f of a plus h minus f of a all over h. And so I now have my f of a plus h, which is 3a squared plus 6ah plus 3h squared plus 1. I take away my f of a, which is 3a squared plus 1. It's all divided by h, and of course don't forget the limit as h approaches 0. And now I get the limit as h approaches 0. 3a squared take away 3a squared, 1 take away 1, so I get 6ah plus 3h squareds, all divided by h. You'll notice you can factor out an h from all the terms. You get the limit as h approaches 0 of 6a plus 3h. Applying the limit, you get 6a. And we know that a is negative 2. So I get my solution for f prime of negative 2 as negative 12.